Hello, this is Jack Jackson. In this video, we're going to briefly talk about composing isometries. That'll be a topic that we're going to be continuing to work on in the next few videos. So if you remember from the last couple of videos, it turns out that we can map the vertices of a scalene triangle to any congruent triangle in the same plane by a series of reflections or by a single isometry. So we have in fact specified exactly how we can take that triangle and map it to the other triangle with a series of three or fewer um, uh, isometries, three or fewer reflections specifically. We also saw that that worked for quadrilaterals, pentagons. It actually works for any polygons or any shape in general. So we came up with this proposition that any pre-image set and a congruent image set in the plane, given that there exists a series of up to three reflections that will map the pre-image on to the image. Okay, and so again, that's why we typically use like a general kind of scalene triangle as as a thing to work with. So we're going to turn out there's actually five types of isometries: identity, transformation, the translations, rotations, reflections, and glide reflections. So let's talk more specifically about composition of isometries. So isometries, rigid transformations, or congruence mappings, are actually functions. Their input is a set of points, the preimage, and their output is a congruent set of points, the image. And like functions you may have studied in the past, we see that these isometries may be composed. Okay, in other words, we can start with the preimage, apply one isometry to obtain an intermediate image, and then subsequently apply another isometry to the intermediate image to obtain the final image. That's exactly what we mean by composing functions. And composing functions, the image of one step becomes uh, the the preimage for the next step, or in other words, the output from one step becomes the input for the next. Notice that the intermediate image is the output image of the first transformation. It's also the input preimage of the second transformation. Any number of reflections, rotations, and translations may be composed in this way, not just two of them. This is exactly what we're doing when we composed a series of reflections in the previous section, where we put together up to three of those in sequence. So next, what we're going to prove is a very foundational result here. The composition of two isometries is also an isometry. Okay? Let A and B be points in a plane. Let T and U be isometries of the plane. Consider the function T compose U. So here we're applying U first, then T, as we normally do with composition. So A prime is U of A, and B prime is U of B. A double prime is T of A prime, and which is T of U of A. And B double prime is T of B prime, that's T of U of B. And the distance from A double prime to B double prime is the distance from A prime to B prime, since T is an isometry. And the distance from A prime to B prime is the distance from A to B, since U is an isometry. Therefore, just by substitution or the transitive property of equality, A double prime to B double prime, that distance is the same as the distance from A to B. So T compose U preserves distance. It is an isometry. So it's pretty simple proof there. Regardless of what kind of isometry we have, if you compose two of them, you're going to get some other kind of isometry. So in fact, it turns out that all isometries may be thought as compositions of the identity, reflections, rotations, and translations. And above, we saw that we can map any triangle or pentagon to a congruent figure with composition of three or fewer reflections. We will investigate this more in a bit in some of the following videos, but in fact, all isometries can be thought of as a composition of three or fewer reflections, so the set of reflections actually generate all the isometries. However, not all isometries can be viewed as a single identity, reflection, rotation, or translation. There's one additional type, one fifth type. It's called a glide reflection, which is just the composition of a translation by a vector followed by reflection over a line parallel to the vector. Once we have that, we will be able to prove that those 5 types are the only types that we ultimately will end up with. So we'll go on in the next video to talk a little bit more about glide reflections.